And we'll get started. So good morning, folks. Good afternoon, evening, wherever you are. And it's December 22nd, the monthly joint food ontology discussion group call. And a very simple agenda plus whatever you'd like to bring up today. I know I'd like to just talk a little bit about how far we got with the wine ontology in Barcelona. And as well, just the two submitted papers that are about FoodOn, food processing, and the whole, basically the FAO presentations, and the fact that the Saturday presentations are going to be live on video finally for everybody to see. We've just gotten through all the permissions stage on that. And then Matthew, are you ready and keyed up to give a 10-minute or so talk about ICICLE and the group here?
Not yet, but I will be when you're done.
Okay, all right. Yeah, a bit early. Admit it's a bit early for me too, because I've been burning the midnight oil on some proposal writing. So, all right. I will go get the agenda going and share my screen. Okay, so okay, so just to talk about the two papers that we submitted, plus Kate Thornton, I see you're on today too. So basically, for this special Semantic Web Journal Special edition on food systems, global food systems, there were three papers plus one agricultural one, and the three are all related to FoodOn. And so we keep prominence if we're accepted in this edition. At the same time, I was kind of hoping for more participation in the whole food scene. So I've left links in the food ontology workgroup doc to each of the papers where you can view them. But what I'll do is I'll go through just the food processing one so everybody can sort of see what we accomplished there. And here we go. So Matthew helped us put it into Microsoft Teams platform for the final editing and submission. Jen, of course, has seen it, and Matthew's seen it, but and handy. But for the others, just to say that we went from the Google version, which was open. I think maybe I passed that link around to everybody, but this version opens up with some general use cases for food processing, and then gets into kind of a more general discussion with respect to Obo Foundry, but just in general about what's needed for food processing. And so there's a little example of meat tenderizing there and what the functions of things are, the processes and the protocols or planned, project plan specification for doing the processing. Then the paper moves into some existing work, kind of what's expected in the industry these days, or in the formal industry, and then over to not formal industry, in the in the sort of engineering computer science world that they're used to. And then the paper moves into a little bit more of an Obo Foundry awareness of food processing, as taking inputs of either material entities or information and outputting material entities or information. But the fact that there are different views upon this, how you can abstract away to just look at an object-only model or process-only model as a summary view. And this object-only model, of course, is just like a snapshot, or it needs to be able to describe everything without necessarily providing all the provenance or the transformation information. A lot of times when people are designing databases these days, they do just only this object-only model, and they don't put any of the process glue bits. Then they often end up getting confused about how to organize things. And I would submit that the secret ingredient to suddenly seeing everything kind of organized in graph databases or traditional databases is to acknowledge that the processes exist by all of that that sort of snapshot state information together. Anyway, so the paper gets into that and into some abstraction. How one might see that processes are involved in the transformation of materials or materials that have qualities. So getting into the state-based view of process modeling, where things change state or systems change state, and how to describe that. You guys can jump in with any questions if you want. I'm basically trying to make it up to the recipe section at the end, so skimming over things here a bit. One of the things we didn't want to really address in this paper is the details of how to actually put down measurements, the qualities or quantities of things being subjected to a process. So that's glossed over, but there is further work coming with Novo Foundry, and easily another paper we could do to get into the details of that with respect to food. There's then into a bit more of a general description of what Novo Foundry is up to, and the other ontologies that we need, like the time ontology for describing process durations and start and stop times, and a discussion of how best to organize process dependency between processes. Then into a couple of models, the exact-2 laboratory processing protocol model, FOVO, and SOSA, right up on SOSA, how SOSA does things, the sensor, I forget what the acronym stands for actually at the moment. Sensor, and that's funny. Although, where's SOSA? Oh, I see, the image just got bumped. Sensor, observation, sample, and actuator ontology, which seems very recent, but it was based on this SSN observation, sensing and observation ontology. It's a bit older than that. And then our beloved PO2 process model that Magali's been working on. The details there, and a comparison sheet across all of them to show where OVO stands with respect to some of these other models and what it needs for sure. Okay, so then we get into finally the applying process modeling paradigms to recipe model. And this is a dive into aspects of the recipe model. I guess I could have been enlarging this for you guys. So the aspects that we look into are just the ingredient lists, the device lists, and the steps in the recipe, not really getting into serving sizes or presentation of the food or the other culinary aspects. So there's a bit of a write-up here about the nuts and bolts of recipes, and into what FoodOn offers so far in the recipe department, which is almost nothing. FoodOn has these 3 relations for how a food product as an ingredient might be fitting into another food product. So this paper was really pushing out this model that we talked about a bit in the past year of a recipe, a food recipe being a kind of plan specification that has ingredient set, device set, and instruction set. There are all kinds of data sets that gather things of the same kind. So an ingredient specification, a device reference, and a step specification, which get down in the details of the actual food materials and the qualities they must have to be part of this recipe, and the devices that you use, and that can include simple things like tables and spoons. That's with an eye to robotics. What's the underlying requirements for automating food processing in that respect? And then all of the underlying plan processes. So working that diagram a bit more, just on that boiled carrots example, has created this more intricate recipe that has 3 components: the ingredient set, which has members being each ingredient and their measures, potentially, how much of it, and other descriptions, necessary descriptions. They can be things that are as basic as drinking water or carrots, and you get to make references straight to FoodOn for that. The devices, including cooking stoves and pots, burners, what their capacities are, how big they have to be to carry this off. And then the instruction set being a set of steps, not necessarily ordered, except that they depend on processes which have to be in a particular order. So that's how the ordering becomes derived or calculated from the recipe model. So then the paper zeroes in on particular basic atomic or fundamental steps of the processing and naming them. So I've actually gone ahead and added some of these processes to FoodOn as elemental bits and what their necessary inputs and outputs are, and whether they utilize devices. This is actually a new relationship, and the whole point of this paper was to say, to achieve this, what do we need in OVO and RO? So in the end, what we wrap up with is a list of needed, well, first of all, that's a sort of chaining of all of these miniature processes together to show how an order, necessary order. And then at the very end, we've got food process ontology requirements, and that's a set of new needed terms into either FoodOn or OVO Foundry or RO, different ontologies. And that ends the technical dive into what a food process and recipe model look like. So you're free to comment more about this because we're going to push this ahead anyway, but there's a reference to, this is what we submitted to Semantic Web Food, and I'm crossing my fingers they like it. So there, I'm going to slow down now and open up some time here for comments if you want.
I have one comment.
Yeah.
You're looking at this in the watered down version of Word that's embedded in a browser.
Yeah.
And so all of the formatting is screwed up.
Ah, right. So indeed, this diagram here in the real copy has a 2-pane. The whole submission was actually 2-pane, right?
Yeah.
Yeah.
Just want to make sure that
right.
People aren't thinking that that's what the final copy looks like.
Right. No. Actually, I should fairly easily be able to show you what the final copy looks like, which is, let's see, clicking on these. Yes.
Evidently, there was some misordering of figures, but I think we'll be okay with that.
Yeah. I've been throwing this sort of a draft version out to a few people. So there is just a few spots where the misordering of
Yeah.
documents occurs of images, and it's down at the bottom towards the PO2 section.
The good news is that what you're looking at here in the PDF looks just like if you had opened that in Word through Teams, you would be looking at that. So it's a truer representation.
Okay.
That's all.
Right. Okay. Some of us were having a few technical problems actually opening Word with it, but anyway, I'm sure that will be resolved soon. Okay.
Yeah, that's just you have a choice when you're on Teams of how you want to open it.
Mm-hmm. Yeah, I literally couldn't open it in Word locally for some reason. I don't know why. Okay. Any other comments, folks? Does this sound like a good, solid progress for the recipe model?
Got some hands there.
I'll wait until the silence is embarrassingly quiet.
No, there's two hands up.
Oh, there are. Oh, good. Oh, good. Oh, thank. So good to hear.
Can I go ahead?
Yes.
Can you hear me? Yeah. Ciao, Demi. I missed the very first few minutes of the presentation, so you might have talked about these, but so this this conception of recipes doesn't include some of the topics that have been discussed also by philosophers.
Right.
So, for instance, recipes that are tied to specific places or to specific people, and yeah, and and so different conceptions in that sense of a recipe, and
Yes.
then there might be other aspects, that are from what I saw at a quick glance what you were showing us. That so I'm just wondering if you talked about this also at the beginning of what to do of those.
Right. So there's a little section here on opening up on the discussion in which we offer the proviso that we don't talk about a number of aspects of recipes, but I didn't explicitly say we don't really talk about the cultural context of recipes or the historical context. This is very much just a little engineering kind of exercise for the planned process itself. So that creates a lot more opportunity to do a lot more work on this. I would hope that a cultural analysis of recipes like the work you're doing could be able to tap into and reference the technical side aspects or qualities of the ingredients, where they're coming from necessarily, who is doing the work in this processing, who has the right to do this work, who has the claim for whatever uniqueness of the recipe, whatever proprietary attitudes towards this.
I think Andrea makes a point, right? But what we've got here, what we've outlined in this document really is less of a recipe and more of a formula, a food formula. Because a recipe, if you go to open a book of recipes, that book of recipes is going to contain all of the other information that Andrea is talking about, the cultural context, right? If I look at my grandmother's, recipe for apple pie, yes, there's the list of ingredients. Yes, there's the instructions. But there's also probably a cute little story of, the first time I made this, whatever, or there may be other things. Yes. There you go. That's a good point right there.
Right. Warren chipped this in, and actually, let me just react to that. I'll say maybe what we should do then is, instead of claiming that this is a food recipe, we could change this label to start to start this
Yeah.
awareness of the broader semantic of what a recipe is. If you'd like.
That's what I'm saying. Either we change it to be like food formulation, or we start including it to including all of these other aspects.
Mm-hmm. I guess I'm comfortable, saying that this is a food formulation, a very specific, potentially specific.
That's the word we use as food scientists, right? So when we talk about being in the food science lab, we say, okay, maybe you have some recipes from home or something that you want to scale up, but you're going to scale it into a formulation.
Mm-hmm.
And that's where we spell out all the various things that we've spelled out essentially in this model right here.
Mm-hmm. I'll just flag that these plant processes, these steps, they can be as simple as boil water. It can be that simple. It may not actually, there may be no performer mentioned. There may be no duration mentioned. Boil an egg might consist of ingredient, 1 egg, some water, device, pot.
That's an assumed performer, which is you. You boil the egg, right? Like, so that's embedded in the assumption of the context of the sentence that you're reading.
Maybe, or from a machine perspective, they can't make any assumptions, so it doesn't even have enough information to perform this stuff or to interpret it if we pare it down to a bare minimum. But that exposes the fact that recipes, as they are documented in human language, are just loaded with assumptions about what the capabilities are of the person or people reading them, which this is an avenue to explore and formalize. So I'm saying, yes, we could call this a food formulation, except that stripped down, it'll look a lot like a food recipe minus the cultural notes. Yeah.
Well, then perhaps there's other components around this that.
Yeah, there's the whole multimedia ability to reference any of these parts. So this food recipe could be accompanied, each instruction set or section of them can be a write-up for the section of the recipe. A food recipe could have document parts, prelude, conclusion, serving notes, and all of these kinds of things, if you wanted to tack them directly into this as an information model.
And is there an arrow missing? I'm just noticing where a food recipe is a type of data set.
So data set is kind of a particular semantic. It's a set of things of the same kind.
Oh, okay.
Whereas we get into food recipe having components, countable parts of things, namely 1 ingredient set, 1 device set, 1 instruction.
I see what you're saying. Yeah, that's fine. You know that branch better than me. Great.
And can I ask again, the notion of component, how is it defined?
Right. So this component is kind of a formal, I think it's an information artifact ontology relation that just very technical, just that a collection, a thing has a part which is a countable part. So it's just a slight difference from the ontology part of in an anatomical sense.
So it's almost proper part. It's the notion of proper part.
Yes.
If I understand, something like that.
Right.
Where it can be an abstract proper part, of course. Yeah. Okay.
Yeah. So lots more work to push this forward. What I did in the first pass is I actually created a file in FoodOn that has so far just this add water example as a bunch of instances. just to show how they could reference parts of the ontology. So if you load this this example, you can load all the little instances of this diagram, and then all of the FoodOn pieces that they refer to. But really, I should finish that by making an instance example of all of these instances of everything that goes into boiling carrots, so that we can play with the possibilities of owl logic and make the logicians happy to see that there's some progress in that area, and as a graph representation of the recipe. Okay, any other comments about that?
Yeah, if I may, thank you for the presentation. It's getting quite complex and big as a model. And I just wanted to say that as I presented in Bolzano last time, we are working now on this fermentation, let's say, schema.
Mm-hmm.
So I think that it's not really, in our vision, it's not really a recipe, because we are more focused on the connection between the various microbial metabolisms. And so we are trying to fit all in place. But I would like to, let's say, be coherent with all of this modeling. So how could we, I don't know if I can see this modeling already into FoodOn, or we can have a chat about this.
Yeah, sure. Happy to talk. And as well, the diagrams, all of the diagrams in this paper are available as draw.io diagrams.
Yeah, I had a look at the paper a few days ago, but didn't have the time to go really into the details of that. But I would like to be as comparable to this model as possible, let's say.
So FoodOn robot tables is now a kind of a consolidated place where all the terms that we're trying to robotize in separate include files exist. And I've moved the food processing process tab here to be the place where we list all of the processes. And so far, this is 80% of them are inherited from Languel. But down at the bottom are new processes that I had to add as a result of this paper. And as a result of the wine ontology work. So in fact, talking about fermentation, my knowledge is petered out, and I need to consult with people who know about fermentation in order to understand kind of the wine aspect, wine fermentation, if you guys know a bit about that technically.
Yeah, there could be quite a lot to say, but as we are doing all of these, just to say, one of my biggest concerns were about the relations.
Mm-hmm.
So we decided to stick to the relation ontology relations, but I was wondering, as maybe there are not the fittest relation for our needs, or we have tried to find the best solution while keeping to the relation ontology to avoid defining any new relationship. And I would like to know if you defined something as a relation for your recipe model that maybe could be useful.
Right. So I have also, any relations that I have are sort of earmarked for inclusion in the relation ontology if they accept them. And right now, FoodOn only has two. Besides, we had RO add, has substance added. I think that was the one early on, and then but we still have has ingredient and has defining ingredients still in FoodOn. But really, those are the only two on relations that FoodOn has.
Okay.
Now, for your business, totally biology focused fermentation terms, I bet. I'm sure RO would welcome them if they're not covered.
Yeah, no, we sort of find the relation that can be used, like keeping it simple, like input, output, and causality, let's say, relation, like causally upstream of or something similar. And we made a model with those, but I was just wondering if you needed to define any new relation also in your case.
Yeah, I ended up just in that particular recipe model stuff, I ended up using a process modeling thing where I didn't have to create relations. I would just focus on these processes that are in between and have these generic inputs and outputs. And so now it's focusing on naming the process that is kind of like, you could create a shortcut relation, but it's really hiding the process that's connecting. And so that may be one line of attack, to see if every time you need a relation, it's actually a process with inputs and outputs to create one thing from another. Okay, we've got some raised hands. I see Duccio.
I have a short notice related to exactly what Francesco was saying. I don't see where the taxonomy of the microbial or species potentially involved in the biotransformation can be inserted in this scheme. Did you think about a specific place? It is also something that I've been considering for KEBI, you know, sort of with the process we're doing with Francesco, we're trying to track, let's say, definition of certain metabolites as a byproduct of fermentation from a specific microbe or else. So did you put anywhere a link to the taxonomy of the species involved in the process?
Okay, so this is actually a great segue to the wine ontology, and how it also exposes how we've done almost nothing with respect to fermentation. So I'm going to flip over.
No. Doesn't mean to be a criticism. It's just
No. I'm happy you guys are doing this, and it's just that everything that you will suggest will be sort of new to me and in this. So I'm going to switch over to sharing the Draw.io app, which has got the FoodOn diagramming, the wine diagramming. So Bolzano was Barcelona, it's actually Terrassa, near where the workshop was, near Terrassa for a week. And I got to work with Sirarat from Embl EBI, who's actually runs the bioinformatics infrastructure, manages the bioinformatics infrastructure at Embl EBI in Hingston in England. But her side passion is wine, and she wanted to get on, and ontology. She's done ontology in the past, and she wanted to do wine. See that, and one of her clients, a couple of her people, including folks at SciBite, want to see the results of that modeling in FoodOn. So this is totally new territory, and my favorite term now is micromodels. I want to create a bunch of micromodels on the FoodOn website that sort of help people understand how you take all these different terms and put them together in very small ways to represent stuff. So the project touched on a number, I'll just flash through them, number of places to diagram and get into wine. So the first tab is just sort of starting to explore some micromodels, and this is all mostly development work. The terms themselves, a number of them, if they have IDs, they are in FoodOn, and we added about 35 terms to FoodOn to cover what we did during the week. But the product-focused view involves a product like grape wine that derives, which is a shortcut relation for processes, derives from a grape cluster, which derives from Vitis vinifera, the taxonomy, and there are cultivars that you can link that way. And so we're actually bringing FoodOn IDs within FoodOn underneath this sort of taxonomic hierarchy. But what you point out is that, of course, that there are all these yeasts that are involved in the fermentation, and you haven't mentioned any of that here. So
yeah, so no, this is just, you know, it's very interesting because what you show points exactly at what I was saying in terms that there is a layer between the grapevine and the end product and the quality and consumer assessment of the product that sees a lot of metabolites that are the characteristics of the type of the cultivar that you're using. So it's connected to grape. And some of the, let's say, metabolites that are there are aroma producing metabolites, so important for the assessment. Some of them are produced by the biotransformation through the microorganisms, and some of them are inherited from the grapevine. So what I was saying is that, you know, when you just read the chemical layer that touches on a number of terms that relate to metabolism and its correlation with taste, and you already have a big divide. And even in CABI is not specified when you describe the chemical terms and the chemical reactions, the actors that are carrying them out. So it's, you know, when we deal with the ontologies for, let's say, biotransformations in general, I think that inserting the microbial, a layer that includes the description of the taxonomy or the taxonomical terms to be used within the process and linked to a set of reactions could be very important if we actually want to use this to depict and you know, to the differences, let's say, between wines and whatever, by capturing the concepts that are carefully hidden behind those reactions.
I agree 100%. And so I think you're going to really like the next few elements, and I'm going to try to give Matthew some time to talk. So that means I'm just going to use a couple of more minutes. So it's all a crash course for me about what wine terminology is. And so at one level, one sort of still primitive level of process modeling, this is where the whole process work starts to show up in other places. That link between the grape cluster and the particular wine product, rose, red, white wine, involves maceration. So this partial maceration or total wine maceration has links between red and white cluster varieties, which create red, rosé, and white wine must, leading to the products. But that's still a primitive characterization. So turns out there are lots of different kinds of food lots of kinds of wine maceration that are in the industry right now. Crash course again: carbon maceration, cold, hot, conventional, limited, extended in terms of time, playing with time or temperature in the process. So we need vocabulary to describe those dimensions. And this is just a very primitive first step by me trying to echo what I'm reading. But where I think I come straight to your domain is realizing that reading papers that say that the actual grapevines themselves contribute a microbiota environment to the maceration process, and that between grape destemming and crushing and processing, playing around with all of those variables about the order that things are done in or what's attached to what as the crushing happens, all affects the output product because of the fermentation steps that are starting to be invoked through all of this. So I think this syncs a lot with what you're talking about. And we would love to refine this model to bring more expertise to it. The paper.
It's nice model. No, I like it. So it's I'll try to contribute practically to that, and then I'll drop a few things if you send me a link and where I find it.
Great. Okay, I
Yeah.
will. I'll pop it right in the agenda. So yeah, it was just fascinating. Found two separate papers that talked about the grapevine, a cluster, the plant anatomical parts of it, and they had different terminology referencing different parts. So it just shows how ontology might be able to save the day here by normalizing some of the stuff. So anyway, there are other aspects. What Sira and I realized was that there are all these different kinds of fermentation. Maybe we could name them. I haven't popped them into FoodOn yet because we were very unsure of what a proper hierarchy was for all of this, for naming these things. And that's why this is blank. And could probably be 100 times bigger diagram. And I've seen your work, Francesco and Duccio, in that area. Wine characteristics also didn't strike up the courage to pop any terms into FoodOn. Matthew, I know you've got a lot of wine ontology stuff waiting to be launched or refined. Others. So this is all an area that needs vocabulary to back it up.
Yeah, I think we can. Yeah, I don't think we need to get into that here and now, though. But I definitely, it would probably be nice to have a call devoted specifically just to this, or even frankly a working group similar to the food processing, kind of thing.
Mm-hmm.
And in fact, I mean, there are so many aspects about this that this could provide a model for the food processing, especially around like the maceration, the fermentation. Those two things should be entirely in sync with each other.
Exactly. Lots of action happening here is influencing the characteristics here.
The characteristics are tough. And I've had these conversations with lots of flavor scientists. I mean, there's just so many things that go into what, especially around what we call flavor. Flavor is very complex. I can manipulate what you think the flavors you think you detect based on manipulating your psyche or the environment that you're in, which has nothing to do with the wine.
Yeah.
And so that's when that needs to be modeled. So modeling flavor and the various inputs for flavor, that's actually something that I would really love, other people who are food scientists or involved in the scientific process of eating, even on the nutrition side, detecting glutamate, detecting, a variety of things, ways that we have of detecting things that go into what we call flavor before we actually can get into what those sensory characteristics are. I think we need to get into how we actually sense them.
So Duccio, you have a comment.
Yeah, no. I completely agree with what has been just said. The aroma field is a minefield, and so it's really incredible. But I do think that really the terminology used in the field, the entire field of fermentation and wine is just one of those things. It really deserves a working group. So I would encourage creating a working group specifically on that.
Okay, great. All right, and then so Sira and I backed away from trying to mint any terms or hierarchy here, even though that was sort of the original intent of the workshop as she wrote it up. Appellation was also a giant explosive field, which I think we could get just a rough handle on by naming and following along with Wikipedia what the different appellations are, so that we can reference them in the semantic web kind of way. So there's a little bit of modeling we did there, but this would all need to be revised by a group. And then terroir, which is back into the agricultural field, describing field conditions and geographical conditions. So any further comments about that before we hand it over to Matthew?
Yeah, just a very short comment. I think that especially if you go for terroir and maybe also for general wine characteristics, it would be really interesting to go on the metabolism layer. I mean, for now you mainly focused on the I don't know, technological aspect. But for example, if you take the wine characteristic tab, you can not easily, but you can connect it to the fermentation if you consider the microorganism and which metabolism are involved. Because, for example, acidity, as far as I know, I'm not really an expert, but there are at least 2 or 3 kinds of acidity in wine. One is sulfur, one is acetic acid, and all of them contribute to the aroma, to the taste, and they're all important to understand what the final product is, maybe. But they are connected to the metabolism of the microorganisms, which basically have one input and some output. Let's say they are acting on some component and producing some other component. So it will be, if you want to go on that layer, it would be very interesting to talk maybe about it. If you want to include this part, because it's a whole chapter, let's say, on itself.
Yeah, so I'm foreseeing in 2022 that we set up a wine working group, and that group have 2 missions. One being just the naming of all the terms in circling around metabolism, fermentation, characteristics, terroir, just naming the things, and then 2,
vocabulary,
attacking little micro models of how things might be connected. So it might be something that's done in tandem, or maybe there's a first pass at the naming of things and then the micro models between them all. Any other comments? Okay, so with that, then over to Matthew to talk about ICICLE.
Thanks. I do think that maybe we need a group, or maybe not a formal working group, but I would love if people want to get in touch with me about talking about flavor and sensory perception. And there's a number of oboe ontologies we could connect to around that as well. There's also psychodynamics and things like that that could also tie into exactly what you're talking about. And maybe it's worth adding beer in there, or maybe just sticking to wine. I'm not sure, but both of them are consumed all over the world. So I'm not sure, but it would be good to have a discussion to talk about those components and how they might relate, and what the working population looks like in those categories. Okay, so I'm going to talk to you guys about ICICLE, this thing right up here, and I'm just wondering if there's a show of hands, how many people have actually seen the video about ICICLE, whether it's even worth showing that as an introduction. I'm not seeing even one hand go up that you've seen it before. So it's a 3-minute video. So maybe I'll show it. So I'm part of an institute that was just funded by the National Science Foundation for $20 million to build AI-driven cyber infrastructure for AI. And the way that we're going to build that is with ontologies and ontology-backed knowledge stores. So why don't I share my screen, and I'll just play this, and then I'm gonna go quickly because there's not much time left, about what it looks like and how this is evolving. I think yeah, this is it here. So.
A policymaker wants to know how land use policies will affect a region's biodiversity. A farmer is concerned about how new weather patterns will affect crop yield, while food distributors and public health officials are concerned with how supply chain disruptions will affect deliveries of nutritious foods to communities. Current technology can provide data and models to tackle grand challenges such as biodiversity, conservation, and agricultural and food system resilience. But it still lacks the infrastructure to link across data and models seamlessly to answer complex questions from diverse stakeholders' perspectives. Even AI experts are challenged to create standardized solutions across domains because a standardized cyber infrastructure integration with AI just doesn't exist. Enter ICICLE, intelligent cyber infrastructure with computational learning in the environment. ICICLE is an institute dedicated to building a national AI-driven computational infrastructure that functions as a utility, much like our electricity, water, and transportation infrastructure. This new utility will enable the delivery of AI to end users with a flick of a switch, enlightening solutions for imminent problems of national, regional, and local importance. ICICLE will provide an operational rationale and framework for a cyber infrastructure that delivers wide and easy access to smart computing, plus a conversational interface that allows stakeholders from diverse domains to ask questions and receive answers informed by currently available data and knowledge. For example, food distributors, emergency food agency managers, and logistics company executives might ask, which food supply chains will likely be affected by an approaching storm? The ICICLE conversation agent might respond with, I will predict future states of your regional supply chain under forecasted weather scenarios and evaluate alternative scenarios. Okay? Upon confirmation, ICICLE would then retrieve satellite data on weather, connect to weather forecast models, acquire inventory data for food producers, processors, distributors, transportation networks, wholesalers, and retailers throughout the region. Use AI models to forecast supply chain conditions from a baseline and alternative logistics that maintain consistent food supply for vulnerable populations, and estimate supply chain disruptions based on historical and current data from other locations, mindful of privacy. ICICLE will go even further by accessing high-performance computing centers to backcast and learn how reconfigured landscape-scale precision agricultural production and distribution systems could integrate with alternative supply chain infrastructure to avoid similar future disruptions. Using an orchestra of smart cyber infrastructure elements, ICICLE produces a symphonic answer that improves outcomes for diverse stakeholders. ICICLE holds the potential to transform today's AI landscape from a series of fragmented tools for use by a few to one where democratized AI and integrated plug-and-play architecture empower diverse end users with knowledge and data flows that are science-based, traceable, transparent, reusable, and trustworthy. Introducing AI for CI for AI. AI for everyone.
So that is
If you're over the age of 35,
oh, no.
this is how much earwax is trapped in your.
Okay, that is the ICICLE sort of promotional video that we made in order to essentially get the grant. Suffice it to say that we are building ontology backbones, but that is only part of the story. I'm outlining here the teams that we have within ICICLE. So we've got an AI foundations team with knowledge graphs. I'm part of that team. Knowledge graphs that are essentially built on ontologies. Certainly FoodOn factors large there. A model commons, adaptive AI, federated learning. This is learning on the edge, so in a browser or on a sensor somewhere. Conversational AI. And then this building cyber infrastructure for AI, this idea of building models and again, edge intelligence, but from a CI perspective. Oops, sorry there. And then AI for CI. What do the knowledge graphs of how an application is actually performing on a piece of hardware look like? You saw the 4 supercomputer centers that are there as part of the team. We've got over 80 investigators from, I think, 9 different institutions. So there's a variety of teams here from all these places. And you can see we've got a visual analytics team. And then we've got these 3 use cases: digital ag, smart food sheds, and animal ecology. I'm particularly into the smart food sheds group. And let me just dive into that a little bit. So we want to be able to answer questions using ontologies like FoodOn, but also other ontologies about food distribution, about various aspects of food in the world, sustainability issues and indicators, organizations, things like that. So I'm going to share a different screen here. And so one of the things that we want to do is actually develop, let's see, I don't want the presentation builder anymore. Why is this? Let me close this. Sorry, one second. There we go. That's what I'm looking for. But there we go. Okay, so we are building a workflow for actually rapidly creating ontologies. So here's one part of it. We assemble a variety of documents to be scraped. This could even be a list of URLs. We have a scraping service that then provides a bunch of document text that is essentially not structured. And we have code for an entity relation extraction service that includes temporal relations. If we were looking at something like a process, like a recipe, as an example. And then we are extracting relations and then matching those extracted entities and relations to in an ontology matching service. And the workflow currently is if something matches, that's great, and we can improve this ontology, or when we can link the components that are in the unstructured data to the ontology. Otherwise, we get into ontology curation, and we identify where that term fits in a specific ontology, the context we're talking about, and then essentially get a human in the loop to curate this stuff. So that's one aspect, and then the other aspect would be, well, how do we, foresee doing that? And part of that is really about I'm just gonna maybe share my whole screen. Sorry, I just had it up a second ago. Oh, there it is. Okay, and then so this idea that we could, choose a file. There's still issues with editing ontologies, and it's still really, really difficult. So what does it look like to have, something that's a little more user friendly in terms of being able to look at various aspects of ontologies? And this is under development with the visualization team now. The idea that I could just pick out a part of an ontology and look at just that part. Don't worry about the actual terms and relations here. This is all just dummy data. But the idea that I could move through various components of the ontology and be able to just hone in on what I want, or intersect perhaps this ontology with another taxonomy if I wanted to look, just at cows or cows and goats, something like that. That's not wired in yet, but that's the kind of functionality that we're really looking at, and to be able to sort of change the visualization as needed for whatever your use case is. So we're moving pretty fast. And if there are use cases and whatnot, that would be great to hear thoughts, and of course we'd love to work with folks. I am running point on collaborations and workforce development and stuff like that, and certainly partnering with FoodOn and the people who are part of FoodOn is an important part of that. So I'll just stop there, and if anybody has any questions, stuff they want to know, have at it.
I don't see hands, but yeah, it's really neat to see a major effort dedicated entirely to ontological recognition and AI, Matthew. So I'm looking forward to all the fruits of that. The user interfaces for creating better editors as well is something I'd like to be involved in. That's a burning need on our side of the fence, and we're always imagining an editor that can help. So we've been working on a list of specifications for what that editor needs. It's very food specific, and so I'm presuming a templated kind of editor will enable working on different kinds of ontology domains.
Absolutely, and we want the editor to actually, be informed by the data or the context of the ontology that of whatever you're looking at, right? In other words, if I pull up, say I load here in this JSON file a list of people or something like that, my editor should know that I'm looking for people, and I should have various taxonomies related to people over here, right? That I can intersect with whatever I have over here. So my editor actually being smart about what's inside it. So a semantically enabled editor, as it were. That's one of our goals. So the editor is on the one hand decoupled, but on the other hand informed, decoupled from but informed by the data that you're looking at. And when I say data, I'm considering ontology as data from a mechanical point of view for a front-end interface.
Well, I wait with bated breath and maybe some input. The output of that, presumably this is a multi-year effort. So are you foreseeing a Gantt chart in which the ontology editing is kind of focused on initially, as well as, or is a particular group or team involved in that?
Yeah, there's a visualization team I think I showed them that. And so this is code that we've been writing in-house in IC Foods. And actually, you know, it's part of the platform that we are building for the IC Foods audience and stakeholders. But I'll be handing that over to the ICICLE folks, the visualization folks, because I think we're already part of the way there. They seem really interested in sort of taking the ball and running with it. And it fits over not just the smart food sheds use case, but the digital ag. It just fits over all the use cases, including introspecting the ICICLE team itself. So what does it look like, you know, from ICICLE's perspective? What can ICICLE do? What are the teams? Who are the people? You know, and so building an ontology out of the gate of our own organization is one of the missions. We're not at the place yet where we have timelines. We're still at the place of strategizing that we want, the directions we want to go before we actually commit to putting timelines around specific activities, if that makes sense.
Yep, understood. Okay, well, with that, shall we wrap it up this month and this year? And I'll send out an email requesting workshop presentations and so on for the next year ideas. We already have one on robotics and food, I think, coming up from one university. So other presentations are welcome to develop both the technology side and the philosophical and cultural awareness side. And Andrea, you can keep us informed of the events that you guys are running at Culinary Mind too.
Yeah, we have a series for next year, you know, that we start in January. We have 6 colloquia, you know, 6 talks, some of which might be of interest to the people here. And then we also started a new series that we call Quarter Bake. That is more of a work in progress and brainstorming. They are not recorded. So are people that like here, you know, they pitch an idea for 10 minutes and then are discussed. And you know, anyone is welcome. You find for now, for the events that are confirmed and scheduled, you find all of them on the Culinary Mind website. They're on the spotlight. So really anyone is welcome, especially from this group. I think it would be great to have someone there.
Okay, I will add a link. I will add a link to that and to this video and to the IFAO videos into the discussion group document, the call log. So thanks very much, everybody, Andrea, Matthew, and all. And wish you happy holidays and look good to see you next year.
Good to see you and Buon Natale dall'Italia.
See you next year. Thank
Buon
you.
Natale.
Yes.
Buon Natale.
Buon anno.
Buon anno. Hi, Matthew. Hi, Danny.
Bye-bye.
Bye-bye.
Bye.
Ciao.